Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. And these self-quizzes are always at the end of a video series. This series is about solving systems of equations. And again, I highly recommend that you go back and look for all of these under that title, Solving Systems of Equations. And these are the three methods that I've talked about. Then we did some word problems. Now it's time for a self-quiz. So, if you try these problems and you're stuck, you really should go back to these first videos. All right, let's look at today's self-quiz. All right, here we go. What we're going to do is solve these two systems of equations by graphing each line. So, grab a piece of paper and a pencil and try to graph these and see if these lines cross. If they do, the intersection point is the answer. All right, for numbers 1 and 2, the line x equals 4 is this vertical line here because all the x values up and down that line are all positive 4, and the y values are anything they can be. So vertical line there. And this is a line here with a 1/4 slope and a 2y intercept. So put a dot at the positive 2 and you're going to go over 4 and up 1. And it turns out that that is the intersection point if you draw it carefully, 4, 3. For number 2, what we're going to do is do the cover-up method because these are in standard form. We're going to be looking for the x and y intercepts here. Now if I cover up this x term here, then I have 3y equals -12, divide each side by positive 3, and I get the y-intercept of -4. Y-intercept. So, -4, I put a dot right there on the y-axis. Same equation, now this time I cover up the 3y term because I'm going to say y is 0. That means x equals 12, and that's going to be, sorry, -12. I forgot my sign there. So it's going to be clear over here to -12, and it turns out that my line is going to look like that. Okay, I ran out of room on that side. Alright, on the second equation, I'm going to cover up my x term and have a y-intercept. So I can divide each side by -3, and then y would be a positive 4. Okay, positive 4 y-intercept. So there it is right there. And if I cover up my y term, that means I'm looking for the x-intercept. Okay, so 7x equals -12. It's not going to be very pretty, but when I divide by 7, I'm going to have an approximate x-intercept of about 1 5/7. So a little more than 1.5, and that's a negative. All right? So there it is right there. Now this is going to be approximate, but if I can draw a straight line there, I realize that the intersection point is going to be right there, -3, -3. Problem. Solve this system by substitution. Now this won't be too bad because x plus y equals 0 in that second equation. That's going to be very easy. I'm just going to go ahead and solve for x. That means that I'm going to subtract y from each side. And so if I rewrite in terms of x, x equals -y or -1y. Okay? Now let's substitute that into the other equation. The other equation is -8x, but we're saying that x is this right here. Now I know it's a lot of negative signs and you kind of have to be careful there, but it turns out to be a pretty simple answer as you can see in red there. So what is -8 times -1y? Well, that would be a positive 8y. So positive 8y plus another positive 8y equals 16. And then we would have 16y equals 16. and y would have to be a positive 1. All right, so I'm going to substitute that in there, and if y is positive 1, then x must be a negative 1. And that's what I get for my ordered pair. All right, next is elimination. All right, the first thing we need to look for is what are we going to eliminate? Well, this first one, number 4, is pretty easy because we have positive 5y and negative 5y. We can add those equations and get rid of the y's pretty easy. On number 5, it looks like we're going to have to do some multiplication, and I see the 8 and the 4 there. So let's multiply in that second equation. I'm going to get 10x equals 0, so x must also be 0. That's my first answer. Let's substitute it into the top equation there. Instead of 3x, it's going to be 3 times 0 plus 5y equals negative 15. Well, 3 times 0 is 0, of course, right? And so 5y equals negative 15, and y must be a negative 3. All right, 0 and negative 3 for that elimination. Pretty easy. Now for number 5, I'm going to multiply that second equation by positive 2, and that way I can get my 8y's to eliminate themselves. So now I would have 11x equals negative 66, and x equals negative 6 when I divide each side by 11. All right, substitution. Let's put it in the first equation. So negative 7 times negative 6, that's my negative 7x right here, plus 8y equals negative 30. All right, that would be a positive 42 plus 8y equals negative 30. Subtract 42 from each side. I'm going to have 8y equals negative 72. Divide each side by 8, and y would be negative 9. All right, I hope you did okay on that. Let's move on to some application problems. All right, read both of those and write 2 equations for each problem and use probably the elimination method to see if you can solve it. Here are the 2 equations. I'm going to say S is the number of seniors, or the price of a senior citizen ticket, and C is the price of a child's ticket. So 2S plus 12C equals 108. 12S plus 13C equals 176. Now compare your S's and your C's, and it looks like a 2 and a 12 are easier to work with than the 12 and the 13. So I'm going to multiply the top equation, all parts, by negative 6. Here are my 2 equations, and the S terms drop out and they are eliminated. That's the next step of the equation. Now we're going to divide each side by negative 59. Now I have a negative divided by a negative, so it's going to give me a positive answer. $8 for a child ticket. Now we always have to go back to a substitution, and let's put it in the first equation. So 2s plus 12 times 8 equals 108. 2s plus 96 equals 108. Subtract 96 from each side. S equals 12, and S is $6 for a senior citizen ticket. All right, how'd you do on number 7? Take a look at my equations. I'm using S for a small box of tangerines and L for a large box of tangerines. So for Kayla, that's her equation. And for Chelsea, that's her equation. Now again, I notice when I compare my variables that 6s and 2s have some related multiples there. So I'm going to go ahead and multiply that second equation by -3. Remember, we need opposite signs here so that those are eliminated. My s terms are eliminated, and I would have -3l equals 54. Divide each side by -3. And a large box of tangerines would cost $18. Substitute it into, how about the second equation? A little bit smaller numbers there. So 2s plus 5l, and we know that L is 18, equals 126. And as I continue through the steps, S equals 18. Now what's kind of interesting here, I know you're saying, all right, small box 18, large box 18, how can they cost the same? Well, that just shows you how when I use a computer-generated math software here, it just happens to work out that way. But normally a large would cost more. So the point is that you can write equations and solve in a system, and there's 3 methods, and most of the time for word problems that's probably elimination is the best way. Thanks so much for watching this video. I hope it helped, and keep watching for more video series in algebra. Alright, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. Alright, study hard,